Welcome back to Business Mathematics 1. I'm Eric from Mathematics Study Program, Faculty of Mathematics and Natural Sciences, ITB. So for today, we are going to discuss exponent and logarithm for the special focus that is on exponential function. Let's start. Okay, let's review the exponent first. Okay, so to the power of 4 is 2 times 2 times 2 times 2. Okay, 2. So the multiplication of 2 4 times. What about 2 to the 3 times 2 to the 2? It will give you 2 times 2 times 2 times 2 to times 2. So if you have 2 to the power of 3 plus 2. Okay, so what about this one? 2 to the power of 3 divided by 2 to the power of 2. So I have 2 divided by 2 times 2. So 2 squared is cancels out. So it leaves you to the power of 1. So what is the relation between 3, 2, and 1? So 2 to the power of 3 divided by 2 to the power of 2 is 2 to the power of 3 minus 2. What about 2 to the power of 0? What about 2 to the power of 0? I can look at this like this. 2 to the power of 2 divided by 2, this is just 2 to the power of 2 minus 2. This is 2 to the power of 0. And this is just 4 divided by 4. It will give you 1. So 2 to the power of 0 is 1. In general, a to the power of 0 is 1. If you set that a is positive and a is not 0. What about 2 to the power of minus 1? I can see this like this. Okay. So if I have 2 to the power of 2 divided by 2 to the power of 3, this is 2 times 2 divided 2 times 2 times 2. And this is just by using the same rule. This is 2 minus 3. This is 2 to the power of 1. What is this? This is 2 to the power of 1. So 2 to the power of minus 1 is 1 over 2 to the power. Okay, in general, I have 2 to the power of minus m. This is the same as 1 over 2 to the power of m. Okay, okay. What about this one? 2 to the power of 2, 2 squared, cubed. So 2 squared, 2 squared, 2 squared, the multiplication. So it will give you 2 to the power of the multiplication. 2 times 3, that is 6. Okay, what about 2 to the half? 2 to the half. Okay, let's just see like this. Open new. So I have y equals 2 to the half. So if I squared this, I have 2 to the power of a half times 2. Okay, yeah. What about this? This is 2 to the half times 2 to the half. So I have 2 times 2 a half times this. So I have 2 a half. This is just 1. So I have y squared is 2. So y, don't forget, this is just positive. So I just look at the plus square root of 2 over 1. The same thing I can use if I have y equals 2 over m divided by n, with m and n is just a natural number. So y to the n is just 2 to the power of m divided by n divided, okay, yeah, and it will give you 2 to the power of m over n times n is to the power of m. So y over n. Don't forget, I want to find the positive one. So y should be 2 to the power of m square root of n. Okay, yeah. Okay. So in general, if you have y equals a to the m over n, see this is the equals as a to the m square root of n, the nth root of a to the m. Okay, yeah. So you have this one and this one. If I have 4 to the 3 times 2 to the 3, this is the same as this. So if I have 4 to the power of 3, 2 to the power of 3, this is just the same as 4, 4, 4, 2, 2, 2. I can simplify this 4, 2, 4, 2, 4, 2. So this just 4 times 2 to the 3. Okay, so if I have 4 to the 3, the same exponent, multiplication, this is just this, okay, yeah, to the same exponent. I can use the multiplication, the division also, and I have this rule. Okay, yeah, this is the same as we have already discussed. Uh, Okay, let's look at some properties of 2 to the x. Okay, 2 to the x. When x goes to minus infinity, you can just plug in minus 10, minus 100, minus 1,000, minus 1 million. It will go to 0. What about when x goes to infinity? 2 to the infinity, 2 to the 10, 100, a million, it gets larger and larger, so it will goes to infinity. What about a half times to the power of x? When x goes to minus infinity, you can plug in minus 10, minus 100, minus 1,000, minus a million, so it will get bigger and bigger. Okay, but when x goes larger and larger, that is 100, a million, 10 million, 1 billion, it will give you goes to 0. Okay, and the graph is given by this. So if I have fx equals b to the x, b is we usually call the base of the exponential function b to the x. When b is greater than 0 and b is not 0, you have the graph is this. So when b is 1 is this, we are not talking about that. For further discussion, we will just talk about when b is positive and not 1. Okay. If b is 2, I have this graph, the pink one. Okay. When x goes to infinity, it will go to infinity. When x goes to minus infinity, it will go to minus infinity. Okay. You can see this as 3 to the x. Okay. Yeah. 1 over 2 to the x, this is a half to the x. We have this property. When x goes to infinity, it goes to minus infinity, it will goes to infinity. When it goes to infinity, it will goes to 0. Okay, yeah? So you can just memorize this. 2 to the x and a half to the x. Okay, yeah? So when b is greater than 1, you have an increasing function. When b is from 0 to 1, you have a decreasing function. This is b a half, 1 over 3, 0 0.7. Okay, yeah, between 0 and 1. But when b, the base is greater than 1, this one, it will have an increasing function. Okay, yeah, so this is the property of exponential function. So the exponential function b to the x, when b is positive and b is not 1, it is divine and continuous. It is divine and continuous for all real. And it should be positive. It cannot be 0. So b to the x should be positive and not 0. And the x-axis is the horizontal asymptote of the graph of f. And the y-intercept is 0, 1. Okay, yeah? Because if you plug in 3 to the power of 0, a half to the power of 0 will give you 1. So the y-intercept is 0, 1. There is no x-intercept because it never go to beyond the x-axis. Okay, yeah? If b is greater than 1, this one, 3 to the x, 2 to the x, 1.3 to the x, etc., then limit b to the x when x goes to minus infinity will give you 0. This one, okay, yeah? It will go to 0. When b to the x goes to infinity, it will go to infinity. Okay, yeah? For b from 0 to 1, you can have the bracket. Okay, yeah? And the function is increasing when b is greater than 1, increasing 2 to the x. When b from 0 to 1, a half, it will be a decreasing function. Okay. And we have a special base that is E. E is 2.71828. How do I find this? It satisfies a limit n goes to infinity of 1 plus 1 over n to the power of n. This is we usually call E. This is an irrational number, yeah. And we have a certain property that the derivative of e to the x evaluated at x equals 0 is 1. Okay, yeah? In graphically, this is the slope of tangent line of graph y equals e to the x at x equals 0. The tangent line always have the slope 1. Okay, yeah, when evaluated at x equals 0. Okay. Um, and this is the special property, the derivative of e to the x. We can use the definition here. and I have this. E to the x can be out, factor out, so I have this one. But what is this? This is just this when x equals 0. What is this? The derivative of this evaluated at 0, but this is just 1, so this is just 1. So I have the derivative of e to the x is e to the x. Okay, yeah, you have to have lots of exercise. Okay, find the derivative of this. Very easy, yeah. E to the power to x is e to the power to x. But if you want to find the derivative with respect to x, I want to find the derivative with respect to x. So I have multiply with the derivative of 2x with respect to x. That is 2. So the derivative of this with respect to x is 2 times e to the 2x. What about this one? The derivative is given by minus 10t times e to the this one using the chain rule. Try to do this by your own, yeah. You have to have lots of exercise this. So this is the application that is simple and compound interest. So if someone invests 100 a year, so he just invests one time, the interest rate is 12% PA. Find the deposit after a year if the interest is simple interest. Find also the deposit if the interest is compounded monthly. Okay, yeah. If calculated using simple interest, we have the accumulated amount is 100 plus 12% times 100. Don't forget, the simple interest, the interest rate is only applied to the principal. So if I want to find the accumulated amount for the third month, it's just the same. 100 times 100 times 1%. Okay, for the third month. The fourth month, the same. The interest is always from the principal. What about the compound interest? If we want to calculate the accumulated amount with interest that is compounded monthly. Okay, yeah. So in the first month, I just have this. This is 1% because 1 month is just 1% the interest. What about the second month? The second month is this plus 1% of this. So the interest is on the principal plus the interest of the interest. Okay, yeah. So this is the A1, the accumulated amount for first month plus 1% times the accumulated amount for 1 month. We can simplify this into this. Okay, yeah. For the third month, I can do the same game and I have this. For the fourth month, I can have this, and you can tell that for 12 months, we have this one. Okay. Now, what about the accumulation amount in a year, the investment in general? If the interest rate is RPA per annum per year, which is compounded monthly, so the accumulated amount after 12 months will be given by this. After 2 years, will be given by this. This is the same, but it is compounded 24 times. Why? 2 years. 2 years, 12 months a year, so 12, 24. If t years, 12 times t. Okay, so this is the interest is compounded 12t times. Okay, so in general, if I want to compound it weekly, so R, this is RPA, R divided by weekly. Okay, compounded interest 1 year, 52 times. If 2 years, 52 times 2. If t years, I have this. So in general, I have this. The principal, the accumulated amount for n years is the principal times 1 plus r to the n. Don't forget, this should be decimal. N is the period of conversion. We usually say the compound, how many times that it is compounded in a year, and t is how many years do you want to have the investment. So I have this as my formula for compound interest. But if this is compound continuously, it means it is compound every second, every millisecond, every microsecond. So every time it is compounded, it will give you e to the rt. Why? You remember this? When n goes to infinity, this is just 1 plus 1 over n times n. So this is something involving e. So that's why you have e to the power of r times t. Don't forget r should be decimal. Okay. And while for simple interest, the accumulation is p times 1 plus the years times the interest rate in a year. Okay, yeah. Don't forget when we are talking about simple interest, the interest is just from the principal, and not from the interest before previously. Okay, and I have the effective interest rate. How do I compare compound interest rate that is compounded annually, semi-annually, quarterly, monthly, weekly, daily, continuously? They must differ in some way, although they have maybe 12% PA. So how do I know the difference? We usually call the effective interest rate. So we want to know if a principal P dollars with interest rate 12% PA, it is compounded semi-annually, that is 1 year just twice compounded, the interest is compounded 2 times a year, is equivalent to which simple interest rate. So I want to find what is R if I compare this with the simple interest rate. The principal is the same. This is the compound interest rate for semi-annually. So I have this, and R, the simple interest rate, is given by this one. And we usually call this the effective interest rate. So 12% PA is the interest rate. So what the effective interest rate when it is compounded semi-annually, it is a little more higher, 12.36. I can do the same thing for quarterly. Quarterly, it means every 3 months. Monthly, daily, continuously. So the effective interest rate is different. So what are the difference between this all of this? The answer is the effective interest rate. Okay, yeah. The formula for interest rate is given by this. Okay, when n is number of conversion, how many times it is the interest is compounded. And the last one is the present value and future value. So if someone invests $100 just one time, it is invested for a year with interest rate 12% PA compounded monthly. So I have in 1 year I have 100. Okay, and this one we also call the future value of this investment. Don't forget the investment is just one-time investment, and you leave it alone until 1 year. And okay, future value. And if someone invests such that in the first year he obtained 100, so how much does he have to invest if he won $100 in 1 year? In 1 year, the accumulated must be 100. What is the principal here? It is 88.75. So you have to invest this amount of money and leave it a year, and in a year you will have $100. Okay, this P we usually call the present value of the investment. The investment, I mean the one-time investment. Okay, yeah. Okay, later we will talk about the logarithm. So today so in this occasion we have talked about the exponential function and its application and the properties of exponential function. Okay, thank you.